All right. Ryan, go ahead and explain why you said this is correct. It's right. You don't know how to explain it? Okay. Can anybody? Anthony, can you explain it?
Alright, yeah. So like the one, you don't have to divide it because the one equals the x, so that's why the x stays the same anyway. And then this is 0 because there's no exponent, so 0 minus 5 is -5. You subtract.
Does that make sense to anybody? What about 0 minus 5 equals -5?
Yeah.
Can we do that? Because, like he said, this is the whole, like, 1, right? So technically your exponent is what? 0. So going by the rule of division, what do you do with your exponents? You subtract them. No? Yes?
Oh.
Yes? No? Guys, keep it simple. Like, this is a crazy... There's a district person sitting in the room, so I won't say what I want to say. But this can get very complicated very quickly, so we try to keep it as simple as possible. All right, so that's one way, and then whatever Anthony said, because I didn't understand what he said. So, all right, but yes, that is correct. Have a seat. And then this last one, applying the same thought process as we did here. Stand up if you said that that one is true. All right, so Ariana, why is it not true?
Because they divided the exponents instead of subtracting.
Yes, this should be 8, technically not -2, because 8 minus 2 is 6. We're trying to get 4. So you're right. They divided when they should have subtracted. Okay, so this is not true. So you should only have 2 that are circled here that are actually true. So the second one and the fourth one. All right, go to number 5. Use a single exponent to write an expression with the same value. So, go ahead, stand up when you have your answer. So if you are multiplying your whole numbers, what are you doing with your exponents? Adding them. So therefore, this just becomes x to the 11th power. Okay? Questions? All right, go on to number 6. All right, so which expression is equal to 4 squared? All right, show your work for each one of these and then circle which one is equal. Remember, if you're standing, you're quiet. All right. Have a seat. So, 16 to the 0 power equals what?
1.
Equals 1. All right, now, this is multiplication, which means I'm adding those two, just the exponents. So a 3 plus 5 equals. Now this one. What do we do here with these two? Do you multiply? Are you sure?
Oh, add. I did it.
So this is my question. Listen. So if we just multiplied here and we added, doesn't that mean multiply too? Parentheses don't mean. I apparently 17 years I've been teaching it wrong. Because last I checked, when you have parentheses, it means what? So then what do you do with those two exponents? You sure?
Yes.
I'm asking you. Y'all are like,
It makes sense.
Why? Because I'm asking? I need y'all to explain it to me. Remember, I only teach 6th grade. I don't know what's going on. So this is my question. This is my question. If we're multiplying here and we're adding, we're multiplying here, why aren't we adding? Raise your hand. Raise your hand. Why aren't we adding there? Kira?
Because it's outside the parentheses, so the exponent goes to everything inside the parentheses.
That means, like, essentially I'm distributing. That word distribute. Remember? Way back in 6th grade? All right, so this actually becomes -1 times -2, which gives me what? +2. So this answer is 4 squared.
That's what I thought.
Looks pretty close to what we're supposed to be doing, but let's check this last one, because that's all for you guys picking this last one to start with. So what does this mean? Division means what? Subtract. So then why isn't this one right? Why isn't this one right? Breda? Because I get to call you this because you made a mistake.
Oh, no, I think the one above it just made more sense. So I'll take the one above it.
But you picked this one first. Why?
'Cause I thought I said 4 minus 2.
Because originally you looked at this as 4 minus 2, right? Which is what you're supposed to do. However, this is what number?
-2.
And when you put it into a problem, you have 4 minus -2, which becomes what it becomes 4 plus 2, which gives you 4 6.
Oh, yeah.
Okay? So you didn't see it wrong, you just didn't show your work, so therefore you got it wrong. Okay. If you don't know me, I'm a big fan of showing your work. Because if we're walking around, we're trying to help you, you don't have work on your paper, there's not what we can do. All right, so the third one is correct. Go to number 7. If y'all missed this one, Lord have mercy. Whew. Write the following as a power. Don't solve it, just write it. All right, have a seat. Jeffrey, what is my answer? 6 to the 4th. All right. Now this one kind of goes back to that whole multiplying question. So it says write an expression that is equivalent to 3 squared times 3 to the -4th to the -3rd power. So remember, you are going to distribute this -3 in. Solve, stand up when you have your answer. that one. Okay, so essentially, if you have it, as it's don't change, actually, like this. Don't change anything, just like this and that, which you get a negative 6 first, okay, that's 12. Essentially, because we small like that. Okay. How do you get a negative 6? How do you get a five? I'll let it go. That's all I did. Then I was like, I don't know if that'll make sense to everybody.
Yes.
All right. We have a little bit of time, but let's go ahead and go over this because for the most part, it seems like we're pretty much done with it. All right, so when you distribute it in, this is one of a few ways you can solve this problem. It's not the only way. Remember, math has a lot of different ways with how different we all think. So one way to do this is to do 3 squared times a negative 3. However you want to write it. I'm not that mathematically 8th grade yet. What I care about is this. Sorry. All right, so we're multiplying. 2 times a negative 3 gives us what? 2 times a negative 3 gives us what?
Negative 6.
So we have 3 to the negative 6th power. So I do the same thing here. So that's negative 4 times a negative 3. So again, I'm just looking at my exponents of negative 4 times a negative 3. Gives us a positive 12. All right, and then from here, what do we do? What do we do from here?
You add your exponents.
So I'm going to do, and I end up with what?
3 to the 6.
3 to the 6th. All right. Explain how you did it, because you and I did it the same, and I don't know if this is right or if this was just like overthinking or what, but how'd you come up with what you did?
Okay, so I just added 2 plus negative 4. Then I times it by negative 3.
So that gave you a negative 2, and then you did times negative 3, which gave you 3 to the 6th. So he, right? Is that what he did? So technically he solved inside and then distributed his negative 3 from the outside. Is that okay? Do we still get the same answer? Okay, so again, this is a good example of 2 different ways getting the same answer for the same problem. Okay? Go to number 9. All right, so write an expression that is equivalent to 5 to the 1st power times 5 to the negative 2nd power times to the 0. Did you have a question, Drew?
How'd you get 3 plus 3 equals 3?
I think I had 3 plus 3.
3 and 6.
I'm at a red room. Negative. Because remember, that was just. Yeah. Yeah, because you're what I meant as a plus. Remember your technical. Right, which when we're multiplying. This is only about exponents, not about the whole. Yeah, that's my fault. That should have been a multiplication. That should be a whole. Go. Told you. But you understood it enough to tell me I did it wrong. So are you really slacking on your education?
You're talking about my education.
But you already know it. You're teaching me, so you're even better.
Push me up there.
Let's go. You coming? Do the next one? No? All right. About another 30 seconds with this one. All right. So, have a seat. Question about this one. With this 0 on the outside, and we distribute this 0 in, or whatever process you want to make with to the 0 power, what is our answer always going to be? 1. So we can distribute this in and do it the mathematical pretty way, doing 5 to the first power times the 0. That gives me 1. And then same thing, 5 to the negative second power times that 0. No matter what you do, your answer is always no matter what. So it's 1 all the way across the board. Does that make sense? Whenever you see to the 0 power, that part is always going to be a whole 1.
Even if it's on the inside.
Yeah, because like we distribute. So distributing this in, we're going to essentially, when you multiply, like you're multiplying, right? So 1 times 0 is what? Okay, so that is 5 to the 0 power, which becomes a 1. And then same thing over here. 2 times, or negative 2 times 0.
Oh, that's everything's 1.
Right, cool. Everything is 1. So whenever you're multiplying to the 0 power, just think of it as a whole number 1, no matter what. All right, move on to number 10. So it says, which number best represents the number of liters in a drop of sweat? So think about a drop of sweat. Think how small that is. Which one of these is a very small decimal? Very small decimal. Well, let me ask you this. Is it going to be a negative or is it going to be a positive? Negative. So both of these are gone. Okay, so at this point, you're just picking the smallest number. Stand up and you have your answer. If you are standing, you are not talking. You've had to lose the privilege of using a pen in my class. All right, so this one is interesting. Have a seat. So this is the easiest way I can tell you guys to think of negative numbers. Because no matter what age you are, negative numbers always give us a hard time. So I'm stuck between these two. Quite a few of you picked -2 as the smallest number, right? So if I want to graph -2 on my number line, 1, 2. That is -2, right? But then I need to show where -7 is. Well, -7 is going to be 5 more to the left. Which one is closer to 0, -2 or -7? Y'all. Woo! Which one is closer to 0? -2, which means -7 is smaller because it's further away.
Not hear that.
You right. So that is the correct answer. All right. Number 11. Perfect squares. Raise your hand and tell me real quick, what is a perfect square? Because this is important. I know we talked about it in 6th grade. If you had me in 6th grade, we talked about perfect squares and perfect cubes. Okay, Kira.
Perfect square, cube.
Let's do squares since we're talking about it.
Or a number multiplied by itself. Like 12 times 2 almost. Oh, that's the answer.
So a number multiplied by itself, what do you mean?
Like 3 times 3 equals 9. 9 is a perfect square because it can be divided by itself and still equal the same number.
Okay, and essentially, stop writing for 1 second. A square has, what do we know about a square? What about the sides? They're all the same. So think about a square. 3 times 3, we know both sides have to be 3. We can't do 3 times 4 because that's not a square anymore. So a perfect square is when you multiply the number by itself. And I'm just going to write think about a square. All right, go ahead and show your work and circle the ones that are a perfect square. Make sure you have work on that paper. Yes, you? Do you have work on that paper?
Yeah.
You sure?
Yeah.
Look at you go. Learning something. You forgot one. You forgot one. All right, so for the most part, we got these. First one, thumbs up if that's a perfect square. 144. All right, what do we multiply? All right, 89. No? Why not, Jeffrey? Right, there's nothing that we can multiply by itself to get 89. What about 48? That's got an even number, so it's got to be a perfect square. No? Why not?
Nothing.
Can't multiply anything? So having an even number doesn't always determine if it's a perfect square? Interesting. All right, what about 64?
Yes.
All right, raise your hand. Tell me, what do we multiply? Eliana? All right. What about 1? 1 is a perfect square because you multiply 1 times 1. Do not forget that. Hint, hint, wink, wink. You might see that again tomorrow. Just saying. All right, next one. Rational numbers and irrational numbers. So which one of these you're going to write? One is rational, one is irrational. Be ready to explain why. Shh. Stand up when you have your answer. What makes one rational, what makes one irrational. Make sure you have like a little explanation. So what makes it a rational number? What makes it an irrational number? does that go with all rational numbers? So you said perfect. Oh, you're saying perfect square is divided by, because it's the square root. Got it. What you got in there?
Cuts off. Yes. Yes. Yeah, I think.
Alright, let's go ahead and go over this. Have a seat. So stand up if you said the square root of 63 is a rational number.
Rational.
Rational. Square root of 63, is it a...
Rational. You said rational or irrational? I didn't know.
Rational.
Oh, rational.
Alright, so I'll ask again. Is the square root of 63 a rational number? Stand up.
Wait, what?
Sit down.
Wait,
Lord.
I
Alright.
thought you said I got this right.
Well, I thought, but maybe I looked at it wrong.
I said 49.
Oh, totally did it wrong.
I knew that.
Yeah.
I knew it.
I mean, your reasoning was right, though. Like, the reasoning was right. All right, so this is irrational.
I always do.
And then, obviously, the square root of 49 is rational. Now, raise your hand. I saw a couple of good things as I walked around. So what's one reason why the square root of 49 is rational?
Perfect square.
It's a perfect square. All right. Brayden, you wrote terminating. What do you mean by that?
Stops. Like it just stops.
Okay, so it ends nice and evenly and pretty, but it can be a fraction that, or a decimal that ends. What about a fraction? Did you figure it out?
I don't even know. I don't know.
All right, so then obviously if rational numbers are perfect squares or they end, what do we know about irrational numbers then? They're not perfect squares. And are they like repeating? How'd you spell it? What'd you say?
Repeats forever.
Repeating forever. So please make sure you get these couple of notes on there just so you know. Pay attention, y'all. All right, number 13. That's where it gets fun. So it says red blood cells are usually about 9 times 10 to the negative 7th meter in diameter. What is that number written in standard form? That means written out. Okay? Remember, your negative exponent, are you moving to the left or are you moving to the right? With a negative exponent, raise your hand. So negative exponents, are we going to the left or are we going to the right with our decimal? All right? So up here, I want you to write negative exponent, move decimal to, you guys said the left or the right? Left or the right? To the left. So you move it to the left. And then go ahead and answer this question when you're done. And stand up when you're ready. stand up when you have your answer. All right, have a seat. The easiest way that I can explain to do this is simply put, for this one at least, and even the positive, like when you have the positive exponent. So you put your number and you just simply hop, skip, jump, whatever you want to call it, that many times. Starting from behind. Why am I starting right here? Why did I start behind the 9 with my decimal?
It's a whole number and that's what it.
Yes, because this is a whole number and this is included in my hop, skip, jump, whatever you want to call them. All right, so I have to go 7 times. So 1,
Oh.
that is literally the easiest way I can tell you how to do this problem. That's it. And then that's your answer. Does that make sense? Okay. Everybody get the notes on that one? Okay, go to the next one. All right, so put your pencils down. This is technically a word problem. I'm not going to worry about it right now because y'all have not been with me since the beginning of the year, but those of you who have had me, what do we always do with word problems? Annotate them, but I'm not worried about it right now. So the predicted sales for the opening weekend of 2 movies are 1 and 9 tenth times 10 to the 8th power tickets for movie Y, and 6 times 10 to the 7th power tickets for movie Z. According to this prediction, how many more tickets will be sold for movie Y than movie Z? All right, I want you guys to solve this the best way you can. Again, if you're not sure, try, and then stand up if you're like, I have no idea. All right, I'm gonna give you about 3 minutes, and then we're gonna go over this one. All right, there are a couple different ways for us to solve this problem. Have a seat. So how many of you guys went the route of doing this times 10 to the 8th power, and then you wrote what this equals?
Yeah.
So you should have, right? 1, 2, 3, 4, 5, 6, 7. Is that right? And then you end up with 190 million. Is that what you guys got? And then same thing for this one. You did 6 times 10 to the 7th, and you ended up with 60 million. And then how many of you guys just subtracted at this step? Okay, so then you have 130 million. But does that tell me how many? Okay, I mean technically it does tell me what the difference is. So I mean essentially you could say this is going to be 1 time, 2 times. How many times will 1.3 go into essentially 1.9? Because remember, this is all fine and dandy. This is the right answer, even when we put it back into that form. But make sure you're answering the question as well. Because I promise you, on your test tomorrow, you're going to see a question that asks 5 times, 40 times, 60 times. So you have to figure out like the amount of times more this is. If you wrote it back in as, was it 10 to the 9th power? Is that what you guys got? 8. 8, sorry. Alright, so, and there are a couple different versions of how to solve this. This is not the only way, this is just one of the ways. Alright, going on to number 15. So it says President Ronald Reagan earned a yearly salary of 3 times 10 to the 4th dollars as president. He served 8 years as president. What was the total amount of money Ronald Reagan earned as president? And then write it in scientific notation. Stand up when you have your answer. because you only put 3 zeros, not 4. It's 10 to the 4th. You did 10 to the 3rd.
Oh.
All right, so let's go ahead and go over this. Again, lots of different ways that you can solve this. So I just did, I added my 4 zeros on, and then what did I multiply this by? What did I multiply 30 by? Or 3 by? Either way. Callie, why? For 8 years, right? So then you end up with 240,000. And then you have to make sure that you write it back in scientific notation. So you go 1, 2, 3, 4, 5. So this becomes 2 4/10 times 10 to the 5th. Okay? Try to keep this as simple as possible. I don't really know how else to make that more simple. You just kind of got to think about what you're doing there. All right, go to number 16. Did everybody get this one? All right, go ahead and get started on number 16. Again, if you're not sure, stand up. If you want to give it a try, go ahead. All right, the crazies are about to be back, so just keep doing what you're doing. Y'all are doing fantastic. You might have to see the old Miss Kenny. Hopefully not. She's a little scary.
Just kidding.
Huh?
This is your third floor, right?
No, this is my wind block. Stab me in the throat. I have
Second?
I have 31 kids in my wind block. Yeah.
Are they as bad as your second class?
No, it's a mixture of like all children. So I just
Okay, that's fun.
Alright, so again, stand up if you're not real sure. Stand up if you're like, I think I know part, but I don't know all. Or stand up if you're like, I think I know it. So you have 3 options.
Stand.
Stand up. I'm about to blow your mind real quick, fast in a hurry. Alright, I'm gonna put some of y'all out of your misery. Because I'm not even kidding you. When I got to this part on the test and I was like going through your test questions and I'm like, what? Because it went against every rule that I had taught myself and I was just like, this don't make no sense. So I broke it down into sections. So this one, 7 divided by 3.5 is what? 2. So that's the first part. We're timesing it.
Oh.
And then I want you to think about the 5 and the -6 on a number line. What's the distance between 5 and -6? 11.
It's 11. Yeah.
That's your answer. Simple. Keep it simple, y'all. I'm telling
That's
you.
it?
That's it. All this crazy,
I actually got that.
like, how'd you solve it?
Exactly how you did it.
Yeah, I mean, honestly, guys, make it easy. Write it down. Like, this part, you know. This part is easy, right? And then here, technically, you can go into multiplying that negative times a negative, blah, blah, blah. No, we don't want to do all that. We don't. We want to keep it easy. So this is just 2 times 10 to the 11th. All right, next. So you're writing this in standard form. This should not be a hard thing. Go. Stand up when you have your answer. Oh, that's what. Hold on, wait. I lied. Go back to number 16. Go back. We're going to write a couple notes on this one. Sorry. If it will focus. So for this part, divide the 2 numbers. And then for this part, find the distance between the exponents. And then think of a number line. Okay, now you can go to number 16 and get started on it. No, absolutely not by iPad games.
Okay.
All right, so you should have number 17 done by now.
You stand
So-
up, right?
What?
You standing up?
Yeah, stand up. Stand up when you have this one done. Like I said, this one should be done for the most part because this is not a hard one. All right. So someone walk me through how to solve this one. Walk me through how to solve this one because this one should be very easy to do. Jeffrey, walk me through. What do I do? Tell me real quick. This exponent, it's positive. So which way am I going? All right, so it's a positive number for our exponent. That means we're moving it to the right how many times? 5? So you should have 4 zeros and then, so it should be 4. That should be your answer. Thumbs up if you got that. All right, go to number 18. We only have 3 left, guys. Well, technically 18, 19, 20. You don't have a 20? Ha! All right, well, we'll do 20 together. 20 is not hard. Anyways. All right, so it says what is the value of 4.5 times 10 to the negative 4th power times 2 and 1800 times 10 to the 9th power. Give it a try. Give it a try. We are not talking. No. Work. I'll give you a hint. You want a hint for this one? Multiply your whole numbers and then multiply your exponent ones. Okay? So multiply the whole numbers and then so it's going to look like 4.5 times 2 and 1800. And then 10 to the negative 4th times 10 to the 9th. Okay, so do that. Stand up when you have your It's both of those. Get your so remember, what you're doing here is the same as always. Like this is still multiplication. Okay? But remember, it's multiply, multiply, multiply. So that's why you're multiplying your whole numbers. Okay? What? Yeah. But really, if you write it that way. Yo, don't bring me back. I got a pencil for you.
The pen did.
No.
I didn't do it.
Right.
Great.
Come in, sit down, and be quiet. Find something to do quietly. There are chairs. If you can't find a chair at a table, there are chairs around the room you may sit in. You're not sitting and talking. Absolutely not. You already have silence. What else you need? Because I got you. Come in, sit down on the floor if there's nowhere else to sit. You good?
Yeah, I was looking for Ian. So I was gonna give this
Ian is right there. puzzle and you finished your study guide, you're reading. But I know 98% of you didn't finish your puzzle, and 100% of you didn't finish your study guide. So those are your options. All right. When you multiply these two, 2 and 1800ths times 4.5, what do you get? My 8th graders, what do you get? Brielle. Ooh, check it again. Check your math. It's not 890.
I got 80.
Nope. Check it. You get 9.81. Check your math. Then over here, remember, we're adding these, right? Do we add those or do we multiply those? We add them. So what do we get when we do -4 plus 9? So that is your answer for this one. Make sense? Yes? No?
More keep circuit.
308. Across the hall from Miss Guthrie in 7th grade. Excuse me. All right. Number 19. So be careful with this one though, because what are we not doing in the middle? We're not multiplying. Now what are we doing? Subtracting. And if I'm honest with you guys, this one did not make a ton of sense, and I actually used a calculator, but I'll tell you this is what your answer is. So why is it that? Why do you think? Look at this number and then look at what you do when you move your decimal. So why do you think? Nobody knows? Because technically you get 499,999,999.998 is your answer. Oh, I know that because I use a calculator because I was like, I don't understand. This is going to be similar to a question tomorrow. So if this is the only one you have a question with, I'll think about that as I'm grading your test. Does that make sense? Because I feel like the rest of them make sense. This one does not. All right, number 20, last one. When do you guys have to be back? 50, right?
Yeah.
Okay. All right, so in 2014, the United States had a population about 4 2/10 times 10 to the 9th. The population of Switzerland is, in 2014, was about 7.5 million. About how many times larger was the population of the United States? All right, solve it. I know you guys don't have this one, but you can solve it on your paper because you have the numbers. And I'll write it for you to make it a tad bit easier. Hopefully it brings back some previous something or others. That look like anything we've done today. Let me move it up so you can see. That may also help a little bit too. So I just took 7.5 million and wrote it as scientific notation. So see if that helps you guys with this problem. Guys, you're gonna put 4.2 underneath your division house. Why did you just spit on me?
What?
So when you're dividing, 4.2 goes underneath the division house, 7.5 goes on the outside. You are going to get a decimal, and then you have to move your decimal with your scientific notation. Okay, does that help at all? So, divide those two. Probably gonna go with a yes. Maybe. But remember, you can't write this answer as scientific notation because that's not gonna tell us our answer. We're asking for how many more, right? Or how many times larger.
Oh.
So divide these two, like I just did on the board. Just not right now, number under the division house. You multiply that by 5. But you can't make that answer because it's asking for how many times larger. Yeah, yeah, because it's division. Remember, do one and then do the other.
How did you track the thing for me?
Yeah. But it's not 50.
It's not.
Yeah, because if you make this decimal, all right, let's go over this one real quick.
This one's.
All right. You have to do this first. When you are dividing decimals, make sure you move your decimal on the outside and then straight up. Nothing I can multiply gives me those two, but when I multiply this by 5, what do I get?
375.
And then when I multiply 75 times what do I get? 6. So you guys are saying that it is 56 hundredths times 10 to the third power, right? Is that what you guys got? Those of you that did it? No?
I just got 26.
You what?
I just got 26. I multiplied 75 by 3 the first time. I got 325.
You can't multiply 75 by 3. You can't because technically this is your scientific notation for 75 million. But this is not our answer. Why?
You have to move to the first one.
Say it again.
You have to move the first number.
How many times am I moving my decimal? Nope. 3. All right, so this becomes, so your answer is 560 times larger. But if you can get here, you're gonna get your answer. Does that make sense? All right, you guys should all be on my Canvas. So if you have any questions or you didn't get some of this, all of this is gonna be uploaded on Canvas. And then I'll be giving you guys your remind codes for your parents tomorrow. Okay? All right, good job, y'all. I will see you tomorrow.
I was just going to report card. Why don't we still have our previous math teacher on the our report?
No, but I have your grades.
So I'm just going to
Why are you speaking? Am I speaking to you? No, sir. Hush your mouth. Yeah, so like she gave me your grades, and then like this one, this test tomorrow, and I think you guys have it.
I didn't turn something in to her, so if I turn that in, would that pass over to
Give it to me. Yeah, you guys are good.
Yeah, cause there was something I haven't turned in.
Yeah, so whatever you have with the stuff, you'll turn it in to me now. And I'll rate it and give you the points for it. Okay?
Bye, Miss Kenny.
See ya.
Well, that's good news.
Yeah, so like if you, like I said, if you guys have missing work, I have all your grades, so everything is under my name now, so just give it to me and I'll get it in the grade book.
Cause I turned in some stuff last night, and the Delta map stuff.
Okay, was it Miss Scarpin or Miss Bryant?
Just so I
Okay, I'll email Miss Scarpin about it and see if she got it.
can. Alright.
Okay? Those of you sitting on the floor, you may now move to a table once the gentlemen are gone. What? What? Yes.
Any of the properties?
Any four that you want.